This is a tutorial on the aspects of quadratic functions. The first aspect of a quadratic function that we're going to talk about are the zeros of a quadratic function. Here we're given the quadratic function y is equal to 3/8 x squared minus 6, and we're given its graph. Now if we want to find the zeros of this quadratic function, all we're doing is setting 3/8 x squared minus 6 equal to 0. Now 3/8 x squared minus 6 is equal to y, so what we're really doing is setting y equal to 0. Now if I want to find out when this is equal to 0, and remember this is y is equal to 0, then I can go to my graph and find out where y is equal to 0. Well, y is equal to 0 whenever you're on the x-axis. All the points on the x-axis have a y-coordinate of 0. So if we want to know when this function has a y-coordinate of 0, we're going to look for the x-intercepts. In this case, x is equal to -4 and x is equal to +4. These x-coordinates should give us y-coordinates of 0. So x is equal to 4 and x is equal to -4 would be the zeros of our quadratic function. Well, let's test if they are. Let's plug in x is equal to 4 into this equation and see if we get a y of 0. If we do that, we'll have y is equal to 3/8. Now our x is 4, so it's 4 squared minus 6. Now 4 squared is 16. And 3/8 times 16 is 6, and we subtract 6 from that and we'll get y is equal to 0. So if we plug in +4 for x, we do indeed get a y of 0. If we plug in -4 for x, we'll have y is equal to 3/8 times -4 squared minus 6. -4 squared is a +16. 3/8 times 16 is 6. Subtract 6, and again we get y is equal to 0. So if we plug in x is equal to 4 and x is equal to -4, we do indeed get y is equal to 0. So if you need to find the zeros of a quadratic function, all you're looking for are the x-intercepts of that function. Now the next aspects of quadratic functions we're going to talk about are the vertex and the axis of symmetry. Here we're given the quadratic function y is equal to -1/8 x squared plus 1/4 x plus 63/8. And we're given its graph and told it has a vertex of 1/8. Now if we look closely at this graph, we can see that it has a 0 at -7 and a 0 at +9. Let's compare these two zeros. What's halfway between -7 and +9? Well, we can take 9 and add -7 to it and divide it in 2. 9 plus -7 is 2/2, so that would be 1. So halfway between -7 and +9 is 1. Well, notice that our vertex has a x-coordinate of 1. So the vertex is halfway between our zeros. And actually, if you look at this line that I've drawn in green here, this line passes through our vertex, and every point on the parabola, or every point of this quadratic equation, is symmetrical across this line. Well, this line is called our axis of symmetry because this parabola is symmetrical across this line. And our vertex is the highest point in this graph, and it lies on our axis of symmetry. So if you ever need to find the vertex of your parabola, you know that it has an x-coordinate that's halfway between the zeros. So if I have a 0 at x is equal to 9 and x is equal to -7 and I wanted to find my vertex, I could find the x-coordinate that's halfway between these 2 points. So I would add those 2 points and divide them by 2. and I would get x is equal to 1. So I found the x-coordinate of my vertex just by finding what's halfway between my two zeros. Now if I want to find the y-coordinate of my vertex, all I do is plug this value for x back into our original equation. If I do that, we'd have y is equal to negative 1/8 times 1 squared, because our x is equal to 1, plus 1/4 times 1 for x, plus 63/8. Now 1 squared is 1, times 1/8 is just a negative 1/8. 1/4 times 1 is just 1/4. And then we're adding 63/8. Negative 1/8 plus 1/4 is just a positive 1/8. And if you add 63/8 to 1/8, you'll end up with 64/8, or that's just equal to 8. So mathematically, once I have my zeros, I can find out that my x-coordinate of my vertex is x is equal to 1. And my y-coordinate then, once you plug that into the equation, is equal to 8. Now that we found our x-coordinate, also notice that this x is equal to 1 is the equation of my axis of symmetry. The axis of symmetry here is the line x is equal to 1. Now there's another way to find your axis of symmetry other than using the graph. Here we have the equation y is equal to 1/5 x squared minus 4/5 x minus 21/5. Here's the graph of that equation. We have zeros at -3 and +7, which means the x-coordinate of my vertex, or my axis of symmetry, should be halfway between 7 and -3. So the x-coordinate of my vertex should be at 2, which it appears it is. It appears that I have a vertex here at 2, -5. But say you didn't have the graph of this equation, or you didn't want to graph this equation. Well, you could use the axis of symmetry formula to find the equation of your axis of symmetry, or find the x value of your vertex. This formula is x is equal to -b over 2a. Now this b and this a come from the standard form of a quadratic equation. The standard form is y is equal to ax squared plus bx plus c. So in this equation, our a would be 1/5 and our b would be -4/5. So if we plug that into this equation, we'll get x is equal to -b, where b is -4/5, over 2 times our a, which is 1/5. Now a -4/5 is a +4/5, and 2 times 1/5 would be 2/5. If you divide 4/5 by 2/5, that's the same as multiplying by the reciprocal. So that's 4/5 times 5/2, and that's equal to 2. So just like inspecting through the graph, we found out that our axis of symmetry is the line x is equal to 2. And I can draw that on this graph. It just looks like this. Now if I want to find the y-coordinate of my vertex, all I do is plug in this x value back into my equation. If I do that, I'll have y is equal to 1/5 times 2 squared, because my x is equal to 2, minus 4/5 times 2 minus 21/5. Now 2 squared is 4, and 4 times 1/5 would be 4/5. 4/5 times 2 is 8/5, so we're subtracting 8/5, and then we're subtracting 21/5. 4/5 minus 8/5 is a -4/5, and then subtract 21/5 will give us -25/5, or -5. So that's the y-coordinate of my vertex. So my vertex is at 2, -5, which is exactly what we found from our graph. So if you don't have the graph of your quadratic equation and you want to find the vertex or the axis of symmetry, you can use this equation. And that completes the tutorial on aspects of quadratic functions.